Hello, and welcome to the Geotechnical Engineering Podcast. In this episode of the Geotechnical Engineering Podcast, I'll be talking with Anna Kotas, a technical sales and business development professional at GeoTesting Express, GTX. We'll be talking about how engineers can manage risk on geotechnical projects through the use of quality laboratory testing programs. I'm your host, Jared Green, and this is the Geotechnical Engineering Podcast, a podcast focused on helping geotechnical engineers stay up to date with technical trends in the field. Before we get started here, this is a free show, and our sponsors help us to keep it free. And now I'd like to recognize our sponsor for today, Menard USA. Menard USA is a specialty ground improvement contractor that works nationally, providing design, build, ground improvement solutions at sites or problematic soils. Menard works closely with civil, structural, and geotechnical engineers to minimize foundation costs for wide ranges of soil conditions, structure types, and loading conditions. To learn more about Menard Group USA or for help on your next project, please visit www.menardgroupusa.com. That's www.menardgroupusa.com. Let's jump right into today's episode. Anna, welcome to the show. How are you doing?
I am well, very excited. Thank you for having me. Big privilege for me this is, so thank you.
Awesome. Well, great to have you on the show today. Can you tell listeners a little bit more about yourself and let them know what you do on a daily basis?
All right. Well, I am a geotechnical engineer who, with 21 years experience, I live and work in Richmond, Virginia, and I work for a company called GeoTesting Express. It is a daughter company of Geocom, and I describe it as one of the largest private geotechnical laboratories in the country, and a little secret that every geotechnical engineer must know about. We test soil, rock, and geosynthetics. It's a very massive, well-organized operation that hopes to serve every geotechnical engineer in this country, if not beyond. And my role is as a liaison to connect geotechnical engineers that have some sort of a need for laboratory testing, for quality laboratory testing, to help them find the right people in our laboratory, maybe sometimes help with transporting of samples, but all those arrangements is my job to make all of that happen. Really, the role is mainly a business development job kind of now. I get to travel the country, meet unbelievable people, and hopefully connect them with a very important service that helps them look like heroes on every one of their geotechnical projects.
Excellent. And did you always know that you'd be doing what you do now?
Or is never in a million years. Not in a million years, Jared. If you told me that I would be mainly doing a social role instead of hiding in a cubicle doing design, I'd never believe it. But I guess there were signs early in my career that I probably the fact that as having been an immigrant kid and having lived in several places in Europe and having to learn languages, communication was one of the most important things that kept helping me get ahead. And so being good at that, I utilized it to my advantage early in my career. And through that was promoted to positions of management. I think at around 32, I was principal. I was a branch manager and principal in an office here in Richmond, Virginia. So, which required an enormous amount of interaction with people. And that's how it developed. That one day I got a call from GTX to do this type of role. And I haven't looked back since and loved every single minute of it. However, I will say, couldn't do it. And I would not be anywhere near as successful had I not had real solid experience in the field from boots deep in a footing, muddy boots in a footing, and all of those experiences that we as geotechs require from rookie years, from project management years and on, to make us the type of senior engineers that know what they're talking about and can actually have a serious conversation at this point in our career.
Excellent. The reality is that that field experience is so important. I know I've talked to a lot of geotechs, and sometimes, why do I have to go to the field? And it's like, there's really no other way you can learn how to do what we do unless you're out there.
Business.
Yeah.
Yes. And it really is amazing. Some of the most mundane work in probably not the best weather, in not the most sexiest settings, where repetitive work in our field made you an expert in a particular test, in a particular method that we were doing, is what later on, years on, the repetitiveness of it means that you can close your eyes and literally recall the test, speak about it eloquently, and without all of those experiences, good and bad, boring and not so boring, I think none of us, would be the kind of engineer that we want to one day become when we grow up. So
yeah, I like that. And Anna, from what I know of you, you're definitely an advocate for the need to raise the quality of the state of practice in geotechnical laboratory testing programs. In your opinion, why is that important?
Well, as far as laboratory testing is concerned, quality laboratory testing, in my opinion, at first we have to start with quality sample. There is a really good geotechnical engineer will tell you that the laboratory test result is only as good as the sample that you bring into the laboratory for testing, which means, having a really well thought out process, even before we step out in the field or stand next to the drill rig, about our sampling techniques, about the preservance of the sample, its moisture, its original orientation, and especially about how to transport it to the laboratory. That much more important when the soils are easily to be disturbed, softer soils, low N values that can easily be remolded if you just pound the sample all the way back to the lab in an unprotected format. So that's really where it starts to me. Delivering a sample that is as close to in situ, representative to the in situ conditions to the laboratory, already minimizes the risks of those differences in what we're actually going to be testing and what we wanted to test originally is very, very critical. Then, good laboratory tests are performed on quality laboratory equipment by folks who are trained and have the skill to be able to do the tests. Experience in laboratory testing matters a lot. Even better when there is a good understanding of soil mechanics and exactly what is happening through all the phases of the tests. But and also getting good laboratory tests done quickly. It's no good to us when we get our lab test results after the reports have been submitted. That data is so critical to our thinking through of the design that it better be accurate and it better be delivered to us fast. But it's very, very important in it's the foundation of our design. It's the numbers that are delivered to you from a laboratory that you've was conducting your testing. Your design is only going to be as good as the numbers that you're using. And so high quality, high accuracy from dependable sources, dependable people that have done your tests are the foundation of the beginning of a geotechnical design. And it's a critical, important, most important phase of a geotechnical project, in my opinion.
Yeah, we definitely depend heavily on the results we're getting from a lab. So there's a lot of variables you just mentioned. So what are some of the consequences of if you conduct poor testing or if you have insufficient lab testing program? What are some of the consequences you've seen?
Well, at best, poor data means poor numbers equals poor design. At best, our reputation suffers. The project design and its costs can be very, very affected, right? Insufficient testing to me means using maybe, as geotechnical engineering sometimes kind of falls into a commodity type of business, and budgets govern our testing programs, etc. And that's when we don't have enough money or enough of a rich enough of a amount of testing that we would want, is when we risk having, in possibly too much need to correlate, too much need to, that depends on presumptive values, whether it be from code or from whatever sources, instead of actual laboratory numbers to design by. This is where the type of conservative values where they sometimes are used for design, and thus increasing the risk, potentially increasing the costs. So all of those things may be affected by insufficient testing and too much dependability on correlation. Poor understanding of laboratory testing is also a very big problem. I don't know if ever it, I don't know, about in your career, but when I was a rookie engineer, I worked for a couple of companies where budget 20 hours for this phase, this much for drilling, this much for design. Yep. And really we had to move on to not only keep billable, but move on to the next project. Sometimes that didn't allow for in-depth learning about geotechnical laboratory testing to really understand the values that I was assigning. Not only that, the correct parameters that I was assigning for the design that I was looking for. Did I really, in my youth, understand that I needed drain strength versus undrained for slope design versus not? That takes mentorship in real life, in real applicable projects, to work through with senior engineers that can help you grasp what it is exactly that you require from a laboratory, and then how to use it. It is difficult, and I was one of those engineers that was told once or twice, Jared, that, hey, now that we have all this information and the laboratory data came back, send it on to our expert in Raleigh. We don't have time for, it's for you to be piddling around with this. We need this done. Send it over to Bob in Raleigh and it'll get done. What? I missed out on learning what it all meant and to be able to use it. And did that make me better on the next project and the next? Probably not. I know that there are many engineers who face the same type of challenges in their daily working routines. It's a kind of a dirty little secret. Do I know enough about this extremely important part of geotechnical engineering? Not all of us have masters and PhDs where we were able to truly spend years and years in the laboratory. Not a lot of us have the type of mentorship or the opportunity to really understand what the values that we are assigning mean. Are they assigned at the proper stress conditions that we would want them in for our design? All of those things are of utmost importance, but very often, I believe senior engineers should double check that their partners and their younger staff do understand what it is all about, because there's a risk of designing using inappropriate parameters. And obviously, that's, again, to affect our reputation, budget, time of the project and how long it would take, change orders that you could face. But at worst, poor design, poor values, let's say example of dam failures. Brazil, 2019, 270 people dead. There is undeniable fact that geotechnical engineers are in one way or another related to such failures. So 1 little parameter, 2 little parameters, but ultimately tying the dots to millions of dollars of costs. And at the end of the day, human lives. It's a very important part of our work. And yes, it's very important that it be understood properly.
That's really important, especially for our younger listeners, those that might be in school right now. And they're in their soil mechanics class and they're in the lab and they're saying, you know, why do we have to learn this stuff? This is why you need to learn it.
Sure.
So thank you for driving some of that home for us. And what would you say are some of the factors that could contribute to errors during laboratory testing or even during sampling
Sure.
and transportation? What are some of the errors that can happen?
One thing that I learned, my eyes were opened. I was, music started singing when I walked into what I call a real laboratory, which is GeoTesting Express laboratory, especially the one in Massachusetts at our headquarters. A big, beautiful laboratory that almost looks like a hospital lab with everybody wearing lab coats, clean, organized, well-maintained equipment that can have a true effect on the ultimate values that the equipment produces. Well-calibrated equipment versus poorly calibrated equipment will have a difference on the data that you're ultimately going to get. Human error plays an enormous role in laboratory error. That's why, for example, in our laboratory, there has been a motto into switching into as much of automated equipment as possible to eliminate those types of factors, such as human error, data entry, and those kinds of things. In index tests, in geotechnical engineering, experience is of the utmost importance. Again, experience, data entry, poor calibrations, even calculation errors in the final reporting have to be considered as potential errors. In automated tests, I would say that sample quality probably plays the biggest role in the occurrence of error or minimizing of the potential of error. So yeah, it's sampling techniques, of course, will have a big role, but quality equipment that is well calibrated, well maintained is probably religion for any good laboratory.
Got it. And what would you say that geotechnical testing, how can it help engineers minimize risk on geotechnical projects? We talk about how bad things happen, but how can it minimize risk?
Geotechnical engineering is already inherently full of risks, right? We have the unknown about our project site, about the subsurface and the varying layers, and there's a limitation on how much of the site we can actually physically explore, right? So, and now in this litigious world, everyone wants accountability for any type of error. So, companies are more and more focused, in fact, high-level management time is being spent on risk management, because now the risks associated with damages to third party, delays, change orders can be even higher than the risks associated with building themselves. So there is no quality laboratory testing programs reduce the unknowns by providing you tangible, accurate information on your mechanical properties of your site. And geotechnical engineering is using using strength, compressibility, and permeability, right? Variations thereof. So to be able to know and trust the most accurate results for your in your design clearly will reduce risk as much as possible. The richer the data, the higher the accuracy of it, the better you get to sleep at night, knowing that you've done everything that you can in your power to minimize risk.
Excellent. Good stuff. Good stuff. Anna, what would you say is your final piece of advice to our listeners? And again, you have students all the way up through practitioners. So that's a wide audience there.
It is. I would say question your data, understand your data, and I think that it should be a little bit of easier to speak up and say, I need a little bit more clarity, understanding, practice. I need more experience. One or two tests and review of one or two laboratory parameters, no kind of expert makes, right? It takes a lot of review to understand laboratory data intuitively. So question it, understand it, push for as rich of a program in testing as possible. We and only we are going to change geotechnical engineering from truly becoming a commodity and allowing budgets to dictate our work, allowing clients to tell me if you ever heard this question. You really need all that testing? Yeah. You really need all that budget? What? Have you ever told your doctor, do I really need all that, all those extra tests? Yeah. Maybe just let's pick 3, right? Out of 10. It's crazy, but only we are going to be able to truly gain back control of our design and what our design is based on, because at the end of the day, our design, any method we use, the model we use are only good as the data that we are using. So question it, ask about it, understand it, and you'll be a better geotechnical engineer for it.
Excellent, excellent. Somebody wants to reach out to you. What's the best way for them to find you?
Oh boy, you can type my name on LinkedIn and you should be able to connect with me. I love being present on LinkedIn and connecting with people. And my email is Kotas@GeoTesting Express. So hopefully I will hear from a lot of you after this. I would love to connect and help in any way that I can.
Excellent. Thank you so much for coming on the show, and keep up the great work. All right.
My pleasure. Thank you very, very much.
I hope you enjoyed the episode today. We would love to hear your feedback, comments, and/or questions. Please feel free to go to geotechnicalengineeringpodcast.com, where you'll find a summary of the key points discussed in today's episode, that being episode 32, as well as links to any of the resources, websites, or books mentioned during this episode. Until next time, we wish you the very best in all your geotechnical engineering endeavors. Peace.